debug Java anywhere. The Java platform debug architecture uses a layered approach to connect a debugger to an application. The debugger can be written in Java and run on the same machine as the application under test, but isn't a requirement. Any platform can host the debugger. Now we are considering debug Java anywhere case, and Java platform debug architecture delivers portability. The Java platform debug architecture uses a layered approach to connect debugger debugger to an application. Debugger can be written in Java and run on same machine as the application under test, but it isn't a requirement. Any platform can host the debugger. Write once debug test everywhere is a variant on Java write once run anywhere claim, and it defined the Java platform debug architecture. JPDA is a client-server system built in 3 application programming interfaces, APIs. The Java debug interface, JDI. Is the client interface used by the Java debugger to access the debugging facilities. The JDI uses Java Debug Via Protocol (JDWP) class. Java Debug Via Protocol (JDWP), which differs from the Java interface definitions associated with the other JPDA APIs. JDWP only defines the format of the packet passed between JDI and the Java Virtual Machine Debug Interface JVMDI. Along with the semantics associated with the data. This allows implementation to exploit any kind of transport mechanism in memory exchange between debugger and the application running on the same machine to TCP IP connections across the internet. Keeping the JDWP generic makes it relatively easy to build a debugger on any platform, not just Java. JVMDI tells a Java Virtual Machine JVM vendor how to implement the debugger interface to JVM. Hiding the application behind this interface lets the JVM be implemented in many ways, from Java bytecode interpreter to just-in-time JIT native code compiler. JPDA APIs can be implemented in Java, though it's not an requirement. Sun provides the JPDA library with the associated class and interface definitions. It's used with the Sun's JVM or compatible third-party JVMs. Embedded JVMs often implement the JVMDI and JDWP with the JDWP supported by a transport mechanism such as TCP IP stack. In this case, the debugger is on a remote system, which is typical for embedded development environment. Pick your Java debugger. The advantage of JPDA is its ability to choose a debugger instead of being restricted to a particular Java platform. often vendors matching debugger will have access to the additional VMs or operating system functionality. However, almost any debugger can handle application development. A number of Java debuggers suit with JPDA. Not surprisingly, Sun has some Java-based debuggers, and most commercial debuggers that provide the Java support use JDPA. There are also a number of open source Java debuggers, including one for Eclipse project. Another is JSWAT from the Blue Marsh Softworks. It's a standalone Java-based debugger that can handle applications on various platforms because it uses JDPA library. JDPA sits below the view of most developers, yet it's still very important component and key to Java's portability. It also gives developers choices that are unavailable through other development environments. Here you can see a non-Java based debugger. You can see the PC debug application, JDA support, JDWP support, and TCP IP stack are inside here non-Java based debugger and PC. Debug application interacts with JDA support interacts with JDWP support, JDWP support interacts with TCP IP stack. Here TCP IP stack interacts with TCP IP stack in standalone JVM, and TCP IP class in multiple JVM system, and here and TCP IP class in JVM based debugger. Here Java application, JVM DI support, TCP stack and TCP stack are inside standalone JVM system. Here Java virtual machine, Java application is inside Java virtual machine here, and JVM DI Java virtual machine interacts with JVM DI support, and JVM support interacts with TCP IP stack. TCP IP stack interacts with TCP IP stack in non-Java based debugger, and TCP IP class in multiple JVM system, and TCP IP class in Java based debugger. Here you can see a multiple JVM system, the Java virtual machine and Java virtual machine, another Java virtual machine here. Here JVM DI class, stub application, TCP IP and TCP IP class are inside Java virtual machine here, and Java application and JVM DI support are inside Java virtual machine here. Here JVM DI class interacts with the JVM DI support in other Java virtual machine here. Here JVM DI class interacts with Java application stub application. Stub application interacts with TCP IP class. Here TCP IP class interacts with TCP IP stack in standalone JVM system, and TCP IP stack in non-Java based debugger, and TCP IP class in Java based debugger. Here Java application is inside Java virtual machine, and JVM DI support interacts with JVM DI class in other virtual machine. Here debug application, JDI class, JDWP class, and TCP IP are inside Java based debugger here, and inside Java virtual machine. Debug application interacts with JDI class interacts with JDWP class, JDWP class interacts with TCP IP class, TCP IP class interacts with TCP IP class in multiple JVM system, and TCP IP stack in standalone JVM system, and TCP IP stack in non-Java based debugger. Now this is the end of my presentation. Thank you very much for watching it.